Next reaction, acid react with base to form salt and water. Accompanied by evolution of heat. The reaction of an acid with base to form salt and water is called neutralization reactions. When the reaction of acid with base to form a salt and water, this reaction is called neutralization reactions. Here sodium hydroxide react with hydrochloric acid and we get sodium chloride plus water. Look this reaction, NaOH plus HCl gives out NaCl plus H2O. The reaction is so called because the acid and the base cancel properties of each other to form a solution which is neutral, neither acidic nor basic. I repeat once again, because we call this reaction is neutralization reaction because the acid and the base cancel properties of each other to form a solution which is neutral. That's why we call this reaction neutralization reactions. Neither acid nor basic. जो हमको मिलता है वो ना एसिड होता है और ना बेसिक नहीं होता. The salt to form and neutralization reaction is not the common salt or the sodium chloride. Salt is preferred to any compound formed by the reaction of an acid and base or vice versa. In this process, heat is always produced. Hello student, welcome in the video of science. Student, in the previous video we have learned about acid. This is our 6th lesson, acid, base and salt. Acid has been derived from the Latin words acidus, which means sour taste. There are two types of acid, organic acids and mineral acid. Acids such as occur naturally in plants and animals are called organic acid, and acid commonly used in laboratory, they are called mineral acid, hydrochloric acid and nitric acid and sulfuric acid. These are the mineral acids. And natural acids such as lactic acid, tannic acid, amino acid, tartaric acid, citric acid, malic acid, acetic acid, ascorbic acid. These are the example of natural acid. And these acid are found in food items just like milk, curd, tea, grapes, tamarind, orange, lemon, apple, vinegar, amla. Then we have also learned about properties of acid. Which are the physical properties of acid? All acid have sour taste. All acid turn blue litmus paper red. Acid are corrosive in nature. Acid conduct electricity in solution form. These are the physical properties of acid. Then we have seen some chemical properties of acid. When zinc combined with sulfuric acid make a zinc sulfate and hydrogen gas. When zinc combined with hydrochloric acid, zinc chloride is made and hydrogen gas. These are the reaction. Now in this lesson we are going to start our uses of acid. Acid are used at many places such as home, laboratories, industries, and the most common use acid are hydrochloric acid, sulfuric acid, nitric acid. But other acid are also used in day-to-day life. Now sulfuric acid is used in the car batteries to make detergent and fertilizers such as superphosphate, ammonium sulfate. It is used in metal treatment and anodizing, and also used in painting and dyes. In laboratories, it is used as a catalyst in chemical reaction and as a dehydrating agent. What is the use of sulfuric acid? It's used in car batteries and fertilizers also to make a detergent, superphosphate and ammonium sulfate. These are the name of fertilizers, superphosphate and ammonium sulfate. It is used in metal treatment and anodizing. Anodizing is a process of on metal like a पॉलिश की जाती है. कोई भी मेटल को कोरोसिव से बचाने के लिए उसको पॉलिशिंग की जाती है, जिसकी वजह से वो नेचर्स में कोई भी केमिकल उसमें रिएक्शन नहीं होती. And also used in paints and dyes. In laboratory, it is used as a catalyst in chemical reaction. As a dehydrating agent. Second is hydrochloric acid is used in the manufacture of chemicals in oil industries to dissolve oil bearing rock and to purify salt. It is also used as declining agent, means to remove the surface rust. The acid are used for making aqua regia, which is used to dissolve noble metals like gold and platinum. Aqua regia is made up of 3 parts of hydrochloric acid and 1 part of nitric acid.
Uses of sulfuric acid. The important uses of sulfuric acid are following. It is used in metallurgy for electrolytic refining of metals. It is used as a dehydrating agent. It is used in storage batteries and lead accumulators. It is used in fertilizers for the preparation of ammonium phosphate, ammonium sulfate and superphosphate of lime. It is used for cleaning of metal surfaces before electroplating. It is used as an acid in laboratories and industries.
Today's topic is hydrochloric acid. Hydrochloric acid stands for HCl. Uses of hydrochloric acid. 1. Helps to digest food in our stomach. Hydrochloric acid is in our stomach, which helps us to digest food. Number 2. Used in cleaning toilets. It is used in the harpics or the things that is used in cleaning toilets. Hydrochloric acid is used in them. Number 3. Used in chemical reaction. We can make any sort of chemical reaction with hydrochloric acid in lab. Number 4. Used in leather industries. In leather industries, many things are made of leather. There, hydrochloric acid can be used and it is used. Number 5. Used in medicine industries. It is used in the industries of medicine. They use hydrochloric acid in the medicine to make. Number 6. Used in steel mills. Steels are made in the steel mills. Their hydrochloric acid is used to make those steels.
Uses of nitric acid. The important uses of nitric acid are following. It is used in the manufacture of dyes, drugs and perfumes. It is used for purification of silver and gold. It is used for etching designs on copper, brass and bronze. It is used as an oxidizer in rocket fuels. It is used in the manufacture of explosives. It is used as laboratory reagent. The major use of nitric acid is in the manufacture of ammonium nitrate.
Here some questions. Test your knowledge. What are natural acids? Natural acids are lactic acid, amino acid, malic acid, tartaric acid, acetic acid, ascorbic acids. These are the name of natural acids. Second question, what happens when a metal react with a dilute acid? When metal react with dilute acid to form salts and release hydrogen gas. For example, if the zinc metal react with dilute sulfuric acid, it's make a zinc sulfate and hydrogen gas. Second, mention 3 important use such as sulfuric and nitric acid in daily life. In sulfuric acid, use in the car battery to make detergent and fertilizers. Second, nitric acid used in manufacturing of fertilizers such as ammonium nitrate and also used in the purification of expensive metals like gold and silver. These are the answer of Have you ever tasted a baking soda? If no, test it. You will find that it does not taste sour or thus have a no acid in it. It is a bitter in taste. Means वो जो taste होती है वो bitter taste होती है. That is a base. Now we are going to start our second point, base. The substance which are bitter in taste and soapy to touch are called bases, and they are usually oxide and hydroxide of metals. What is meant by base? The substance which are bitter in taste and soapy to touch are called bases, and they are usually oxides and hydroxides of metals. Here activities number 3, test for the bases. Take some baking soda used in the kitchen. Make a solution with water. Now rub it solution between your finger. How do you feel? You will notice that the solution feels slippery, and this indicates that baking soda is base, as bases are soapy to touch. Second example, sometimes we suffering from acidity due to the indigestion of food that we have eaten. हमको acidity हो जाती है. There is a sour taste in the mouth and burning sensation in the chest. हमको थोड़ी सी जलन लगती है कि जैसे हम चेस्ट में थोड़ी जलन हो रही है. We often take acidity such as Digene or Gelusil. These antacids are base which neutralize the reaction of the excess acid in the stomach. The antacids usually contain magnesium hydroxide and aluminium hydroxide. क्या होता है जब भी हम जेलुसिन या डाइजीन लेते हैं, दिस टाइप्स ऑफ मेडिसिन हम मार्केट में मिलती है, तो जब हम लेते हैं तो क्या होता है, हमारी जो स्टमक में एसिडिटी हमारी बढ़ जाती है, और जो एसिड बढ़ जाता है उसको हम, और ये जो होती हैं ये बेस होती है, तो एसिड जो पेट में क्या एसिड और बेस जब मिक्स होते हैं तो न्यूट्रलाइजेशन होता है, न्यूट्रलाइज होता है, हमारा एसिड सॉल्ट एंड वाटर में कन्वर्ट हो जाता है. दैट्स व्हाई वी आर फीलिंग वेरी वेल व्हेन वी टेक दिस टाइप्स ऑफ एंटासिड्स. The most important and commonly used bases are sodium hydroxide, NaOH, calcium hydroxide, CaCOH2, and potassium hydroxide, KOH. These are the strong bases. They are corrosive in nature and can cause the burning injury to the skin. Means ये हमारी स्किन को बर्न भी कर सकते हैं. These strong bases are soluble in water. The bases which are soluble in water are called alkalis. What is meant by alkali? Strong bases are soluble in water, and those bases which are soluble in water are called alkalis. Some bases which are not soluble in water are not alkalis, and we are say all alkalis are bases, but all bases are not alkalis. Means सभी जो alkalis रहते हैं वो बेस है, बट सभी जो बेस होते हैं वो अल्कली नहीं होते, क्योंकि ये सभी बेस वाटर में सोलुबल नहीं होते. Some bases such as Magnesium hydroxide, ammonium hydroxide, copper hydroxides are weak bases. What is the name of weak base? Magnesium hydroxide, ammonium hydroxide, copper hydroxide are weak bases.
Antacids are acid-reducing medications that directly lower the acidity of stomach contents. They are used to treat conditions like gastroesophageal reflux disorder, or GERD, and peptic ulcer disease, or PUD. When combined with anti-flatulent medications like simethicone, they also help decrease gas production, which provides comfort and relief to clients experiencing gas or bloating. Antacids can be made up of aluminum, magnesium, calcium, or sodium compounds. Common antacid medications include aluminum hydroxide and simethicone, magnesium hydroxide and aluminum hydroxide, magnesium trisilicate and aluminum hydroxide, magaldrate, calcium carbonate with magnesium hydroxide, and sodium bicarbonate. Now, when antacids are taken, the medication reacts with gastric acid and results in the production of neutral or low acidity salts that increase the gastric pH. Additionally, the enzyme pepsin that normally helps digest protein is also inactivated. The outcomes of these reactions are a decrease in gastric acidity, enhanced mucosal protection, and a reduction of the symptoms associated with GI conditions such as GERD and PUD. Antacids can cause several side effects. If they are taken for an extended period of time, they may alter aluminum, calcium, sodium, and phosphate levels. Other general side effects of antacids include belching, constipation, flatulence, diarrhea, and gastric distension. Since all antacids increase gastric pH and can potentially bind with other drugs, absorption and effectiveness of medications taken along with antacids can be affected. For example, they can increase oral absorption of medications that are weak bases, such as quinidine, an antiarrhythmic and antiparasite medication, and decrease the oral absorption of medications that are weak acids, such as warfarin sodium. Also, antacids can chelate or bond other medications in the GI tract, resulting in new complexes that are not absorbable. This is especially common with medications such as tetracyclines, a class of antibiotics. So, spacing out antacids from other medications by 1 to 2 hours, or as prescribed, is important. Depending on the medication's compound, side effects can vary amongst different types of antacids. For aluminum-based antacids, constipation, hypophosphatemia, which can manifest as anorexia, malaise, tremors and muscle weakness, and aluminum toxicity with prolonged use can occur. A common side effect of magnesium-based antacids is diarrhea. However, when combined with an aluminum-based compound, it is less likely to occur. Calcium-based antacids can cause hypercalcemia and metabolic alkalosis, and sodium bicarbonate antacids have the potential to worsen hypertension and the risk for heart failure, largely because of the sodium content it contains. There are several important contraindications that should be considered before administering antacids to clients. Aluminum compounds, for example, are contraindicated in clients with low serum phosphate levels because the addition of aluminum can lead to hypophosphatemia. Magnesium compounds should be avoided in clients with abdominal pain, nausea and vomiting, diarrhea, severe renal dysfunction, fecal impaction, rectal bleeding, and if they have a colostomy or ileostomy in place. Calcium compounds are contraindicated in clients with hypercalcemia and hypercalciuria, severe renal disease, renal calculi, dehydration, and GI bleeding or obstruction. Finally, sodium compounds should be used with caution in clients with hypertension and heart failure. Antacids should be administered and taken on a regular schedule, and for maximum therapeutic benefit, it should raise the gastric pH to above 5. Clients should be educated to chew antacid tablets well and follow them with water or milk if not contraindicated. For antacids that come in liquid form, be sure it's shaken before taking. If you're administering an antacid via nasogastric tube, or NGT, be sure to flush with water following the medication. The safety of antacid use in lactating women hasn't been established yet, so it should be used with caution in this client population. Finally, just as with all medications, it's important to keep it out of reach of children and to be sure your client has consulted their primary care provider before beginning this over-the-counter regimen. Alright, as a quick recap, antacids are acid-reducing medications that directly lower the acidity of stomach contents. They are used to treat conditions like gastroesophageal reflux disorder, or GERD, and peptic ulcer disease, or PUD. When combined with medications like simethicone, they also act as an anti-flatulent. Antacids can be made up of aluminum, magnesium, calcium, or sodium compounds. Depending on the medication's composition, side effects can vary amongst different types of antacids, which can include belching, constipation, flatulence, diarrhea, and gastric distension. There are several important contraindications and client education that should be considered by the nurse before administering antacids to clients.
Here is activity number 4. Take a magnesium ribbon and burn it. Magnesium burn with a dazzling white light. It forms magnesium oxide as white ash, which is soluble in water. Now test the solution. Dip a red litmus paper. What happens? It turns blue. Means it clearly indicates that the magnesium oxide form magnesium hydroxide, which is base. हमने पहले देखा था कि base जो एसिड में अगर लिटमस पेपर डालते हैं, which litmus paper we dip into acid? Blue litmus paper turn into red, और base में the red litmus paper turn into blue. The reaction takes place in the activity. क्या रिएक्शन होगी इस एक्टिविटी में? Twice Mg plus O2 means magnesium plus oxygen gives out a twice MgO means magnesium oxide. Then जो magnesium oxide था उसमें हमने पानी डाला, तो MgO plus H2O we get MgOH by 2 means magnesium hydroxide. यहाँ पे हमने 2 रिएक्शन किए. फर्स्ट हमने magnesium ribbon burn into the air, we get magnesium oxide. Then we magnesium oxide dissolve in the water and then it turn into magnesium hydroxide means MgOH by 2. For understood, look this activity which help you for understand this activity very well. Next point, general properties of bases. Bases are usually oxide and hydroxide of metals. The physical properties of base are they are bitter in the taste and soapy to touch. They turned red litmus paper blue. They react with acid and form salt. The reaction is known as neutralization reaction. They are described by the presence of hydroxyl group means OH, and some are corrosive in nature and cause burn injury to skin. These are the physical properties of base. तो बेस आपको अगर आइडेंटिफाई डिस्क्राइब करना है तो लास्ट उसमें जो ग्रुप है हाइड्रोक्सिल ग्रुप रहता है OH. आप जैसे कि आप अगर एसिड है तो H से आप उसको अंडरस्टैंड कर सकते हैं, वैसे ही अगर बेस है तो OH ग्रुप वहां पे आपको दिखता है, तो वी हैव इजीली उसको आइडेंटिफाई कर सकते कि ये बेस है और कि ये एसिड है. ओके.